السلام عليكم ورحمة الله وبركاته. Here is an introduction to the mechanical vibrations submitted by me, Mohammed Shakir Zahid, to our instructor, Dr. Fatrani Mohammadin. History of vibration. Actually, people became interested in vibration when they created the first musical instrument. The mathematical theory of the non-linear vibrations began to develop in the works of Pioneer and Lyapunov at the end of the 19th century. After a long time, actually, till about 40 years ago, vibration studies were done by using gross models with only a few degrees of freedom. That was not enough. Actually, the importance of study of vibration clears us to why we should study vibration. Most human activities involve in vibration. For example, we hear because our eardrums vibrate. Our eardrums vibrate. Machine component subjected to vibration can fail because of material fatigue, resulting from what? From cyclic vibration. It should be considered in design the cyclic vibration. When natural frequency happens together with the frequency of the external excitation, resonance occurs, which deals to the failure also. It should be considered. The resonance should be considered in design. The final purpose actually is to reduce the vibration in design of machines or machine spark. Definition and parts of vibrating systems. Definition of vibration: any motion that repeats itself after an interval time is called vibration or cycling. Repeats interval time. For example, it repeats 1, 2, 3. This is actually vibration. A vibratory system in general includes 3 parts. The first one is mass, that stores consider mass that stores the kinetic energy, springs that store the potential energy, and damper that lose gradually the energy. Numbers of degrees of freedom. What is the numbers of degrees of freedom? The number of degrees of freedom actually it is the minimum number of independent coordinates required to determine what the position of parts of a system at a time. It is the number of degrees of freedom. For example, 1 degree of freedom means that an object restrained in all directions except only in one direction, it can move. A system with a finite, it is defined with a defined number of degrees of freedom. With a finite number of degrees called discrete or lumped systems or lumped parameter system. When a system it's not defined its number of degrees of freedom, it is called a continuous or distributed systems. We have unlimited in this type. We have unlimited number of degrees of freedom. We classify the vibration according to different categories. The first one, free and force. When vibration is free, that no external force acts on the system, or in other words, if you explain it clearly, if a system attached to a force or a force enters the systems or or creates vibrating in the systems, then in it's unattached, the system is still vibrating with itself. This vibration after disconnected force called free vibration. Or forced vibration means vibration actually occurs with an external force. Damped and damped vibration. Damped vibration when no energy lost in a resistance during oscillations. When there is a resistance during an vibration, at the same time no energy lost, it means damped. It's damped vibration. Otherwise, it's undamped vibration. In category of the linearity, vibration could be linear when when the components of a system, for example, spring or mass, behave linearly. If these components do not behave linearly, it could be non-linear vibration. Deterministic or random vibration when the magnitude of the inputs, such as force, it is known in a given time, it could be deterministic vibration. Otherwise, it's a random vibration we cannot define. For example, if you look at these two figures, deterministic uh, vibration, we can count the number of the cycles, we can count it. Figure A. And the part B, we cannot count. It is random vibration. To analyze actually a vibration systems, we have to, first of all, we have some steps. In first step, we have to model mathematical equations to actually represent the behavior of the systems. The second time, we can derive this mathematical model that we model it in first steps by using some principle of Newton's second law or D'Albert's principle or principles of the conservation of mass. We can derive these equations to describe what's the vibration of the systems. The third step is a solution of the governing equations. The equations of motion must be solved to find the response of the vibration systems. It should be solved. The fourth is interpretation of the result. The result must be interpreted with a clear point of view or clear analysis. To be clear, actually. What is a spring or a spring analysis? Actually, the spring itself is a mechanical link. In most cases, in most applications, is assumed to be it's assumed to have negligible mass or damping. We have non-linear spring when the force is represented by this equation: F equal ax plus bx cubed. It's clear that this equation is non-linear because we have cubed. When a greater than 0, when b equal to 0, at this time the equation shows that the spring could be linear. When b less than 0, the spring will be soft like that. As described in the textbooks. Springs when springs are in parallel, we can actually sum the constant of a spring, this k. We can have a k equivalent equal k1, k2, or if you have three springs in parallel, k3, k4, like this. k1 equal k2, k2 plus k3 plus k4. If we have springs in series, we can also have k equivalent, that is equal 1 over k1 plus 1 over k2 or 1 over k3, like this. But this is explained in these equations. Mass and inertial elements. The mass or the inertial elements assumed to be in a rigid body, except the mass. It can gain or lose energy whenever the velocity of the systems change. For example, here the various fluid levels represent the mass elements, and elasticity of the vertical members represents what? Represents as a spring. It's an idealization of a building actually, with more degrees or multiple degrees of freedom. How do we combine masses? We have two cases. Either the masses or internalization masses connected by a rigid bar, either translation and rotational masses coupled together. When translation masses connected by a rigid bar, the equivalent mass will have the same kinetic energy as the system has, according to this equation. Mass equivalent equal mass 1 plus the length of the bar from point 2 to point 1 completely square, like mass 2 plus length of the mass 3 actually, from reference point to the length of the mass 1 completely square mass 3. In case 2, we have one translation and one rotational masses coupled together. At this time, either we can have equivalent translation mass, that is equivalent mass of the two masses is given by this equation. Mass equivalent equal mass plus g over r squared, if we consider g as a moment of inertia. Equivalent rotational mass, or either we can equivalent rotation mass. This g equivalent equal g naught plus mr squared. Damping and its types. What is damping actually? The mechanism by which the vibrational energy is gradually converted into heat or sound is known as damping. This is the definition of damping. We have viscous damping, column damping, or material damping. Viscous damping, when mechanical systems vibrate in a fluid such as air or water or gas, the resistance offered by the fluid to the moving body causes energy to be distributed in. Or column or dry friction damping. The damping force is constant in magnitude, but opposite in direction to that of motion of the vibrating body actually. Material or solid, or we can call hysteretic damping. When a material is deformed, energy is absorbed and dissipated by the materials actually. These are the types of the. Next one, we have harmonic motion. What is harmonic motion? If a motion is repeated after equal intervals of times, it is called periodic motion. The simplest is a general definition. When a motion is repeated after equal intervals of time, the intervals equal, it is called periodic motion. The simplest types of the periodic motion is what? Harmonic motion. But when we go deeper, when the acceleration is directly proportional, it is derived in the textbook, how it is directly proportional to the displacement. It's called simple harmonic motion. If we look at this figure, that is a car yoke mechanism. Yeah. When then this bar A rotates according to about point O to slides the solid rod P actually. When it rotates, the point C either goes up or either goes down. A displacement by amount of x occurs. For if you look at the graph from point O, from the middle it goes up by x amount, and from the middle it goes down for by x amount also, by x amount. Actually the x is equal a sine or cosine omega t. Omega, it means the rotational speed of the bar of A at how much time it rotates. This is short description. In summary, we presented actually the fundamentals concept of the vibration with a short story and background and how the vibration study is important. Next, we see the degrees of freedom and discrete and continuous systems, or different types of the or classes of vibration. Then we talked about how to analyze the vibration systems. There were some steps. One of the fundamental types of the vibration that was important. We see actually we saw that is harmonic motion. This was a short introduction to the mechanical vibrations. Thank you. I hope I explained in better way, but neglect my mistakes. See you inshallah. Assalamu alaikum.